Good morning. All right, so we're going to pick up where we left off, still section 1.4. We're definitely going to finish up 1.4 today. So that homework that's due by midnight tonight is still due. Hopefully you've been working on it all along. So you should only have a few more problems maybe on the compound fraction stuff that we haven't covered yet. But that is due by midnight tonight. Please let me know if you have any questions, right? You can always send me questions using the Ask My Teacher button in there. And then the goal right now is to try to finish up chapter 1 by like middle of next week. So the plan right now is to post that test probably Wednesday of next week and have it due Friday of next week. So just so you kind of have an idea, that's kind of the goal right now, is to finish up the chapter and get that test in by the end of next week. Okay, which means also that the next homework will probably be due around that same time. So once we get into 1.5, hopefully today, then you'll be able to at least get started on the 1.5 through 1.10 homework also. Okay. Any questions, comments, concerns before we get started today? All right. Now, as always, if you think of anything, just let me know or email me. I'll be happy to answer any questions you got. All right. So compound fractions. So a compound fraction is any fraction in which the numerator, the denominator, or both are fractions. Okay. So basically, if you have a fraction in the numerator of a fraction, or a fraction in the denominator of a fraction, or a fraction in both, then we have what's called a compound fraction. We don't like compound fractions. Okay, so we always want to simplify these things down as much as possible to get it just to a fraction rather than leaving fractions within a fraction. Okay, so that's what we're going to be looking at next. Okay, so this will be an example of a compound fraction. In this example, we have a fraction in the numerator and a fraction in the denominator. Okay, so in this case, we've got to get rid of both of those fractions. All right, so if we focus first just on the numerator fraction, if I wanted to get rid of that fraction somehow, what could I do? So the x over y there, if I wanted to get rid of that fraction, what would I need to do? Okay, so we could, right? So we could find a common denominator in the numerator and denominator here. So let's do that. So if we find the common denominator up top, right? So just so we can combine those, what would be the common denominator for just the numerator? Just y, right? So what would I have to multiply the 1 by so that I would have a common denominator? Okay, so we have to multiply by y. But remember, we have to multiply by y over y in this case because we need the same thing on top and bottom, right? All right, now let's look at the denominator. What am I going to have to multiply that 1 by so that I can actually get a common denominator there? Okay, good. So x, or in this case, x over x, right? Because again, we need the same thing in the numerator and denominator. All right, now once I do that, what am I going to have in the numerator then? Okay, good. There's a y over y in place of the 1 now. And because I have that common denominator, I can combine those fractions. So what would that give us if we combine those? Good. So we're going to have an x plus y all over y. Any questions on how I got that fraction in the numerator now? All right, let's look at the denominator. What's our fraction going to look like in the denominator now? Good, right? So we're going to have an x minus y, combining those numerators, and then our common denominator this time is x. Now, obviously, we're still not done. We still have a compound fraction, right? There's still a fraction in the numerator and a fraction in the denominator. But what can I do with those fractions now? Multiply by what? The reciprocal, right? So we're dividing fractions, which just means we're going to keep, change, flip, or multiply by the reciprocal. So the whole thing just turns into x plus y over y times the reciprocal of the denominator, which is going to be x over x minus y. So that's the whole purpose here of combining everything in the numerator, combining everything in the denominator. So then we just get the division of two fractions, and then we can just multiply by the reciprocal. So now when I multiply these two fractions together, what's my numerator going to be? Good. So we can just write that as x times x plus y. If you want to distribute that out, feel free, right? You get x squared plus xy. What about our denominator? Good. So now we've got a y times x minus y. Notice here, there are no common factors, nothing that's going to cancel out. I can't simplify that anymore, but I no longer have a compound fraction, right? Because there's no fractions within my fraction. So this right here is my final answer. So in general, that's going to be our process, right? Try to combine as much stuff in the numerator and denominator as you can. Try to get it down to at least a fraction in either the numerator or denominator or both. And then we can just use our properties of division for fractions, multiply by the reciprocal, and that'll get us down to just a fraction instead of a compound fraction. Any questions on that one now? It's not necessary. Honestly, I like it in factored form because down the road, when we're trying to solve these things, having the factors is actually going to be beneficial to us. So I would probably just leave it factored there. Okay. But if you do it's not wrong, right? Any other questions there? All right. So we've got another compound fraction here, right? Fractions in the numerator this time. We want to simplify this. All right, so what's the first thing we need to do here? We need a common denominator. Good, because we need to be able to combine those fractions in the numerator, and then again, we can just divide by the reciprocal. So in this case, what's the common denominator going to be for the numerator? Good. The a and the a plus h, right? So a times a plus h is our common denominator. That means this first fraction is going to be multiplied by what? Good. And whatever we do to the top, we have to do to the bottom. So it's a over a. And then we're going to have to multiply the other fraction by what? Good. The a plus h. And again, whatever you do to the numerator, I have to do the same thing to the denominator. Okay. All right. So now when we simplify that, in this first fraction, we're going to have a over a times a plus h minus, and this other fraction is going to give us a plus h over a times a plus h. And then don't forget all of that is still over h. Any questions on that step? All right, now I want to combine those fractions in my numerator, right? So when I combine those, what's that going to give us? Okay, almost. Be careful here, right? We're subtracting the a and we're subtracting the h, right? So instead of an h, it's actually going to be what? A negative h, right? So we're going to have negative h over a times a plus h all over h. Because again, just think this whole thing is grouped together. That negative now gets distributed to both of these terms. And so a minus a cancels out, and then we have a negative h in our numerator. All right. Now, once we've done that, now we can do what? Good, right? So keep, change, flip, multiply by our reciprocal. So we're going to have negative h over a times a plus h. And then what's the reciprocal of our denominator this time? Okay, so h over 1 is what it would begin with, right? Because I could write this as h over 1. So what's its reciprocal going to be? 1 over h, right? Okay, so just make sure, think of h as a fraction, h over 1. And so its reciprocal is now 1 over h. So now when we multiply this together, what should we end up with? Okay, so we could, right? So here's what I want you to remember though. Anytime you have common factors on top and bottom that'll cancel, we can go ahead and do that before we multiply, right? Do I have any common factors here in the numerator and denominator? There's an h, right? Okay, so that h in this case is actually going to cancel. And so we're really just left with the negative from the original h. So that's going to give us a negative 1 up top. And then in our denominator, we're just left with an a times a plus h. Okay. Now, if you had multiplied straight across first, that's fine. Then you still have to recognize there's still an h in the numerator and denominator. Make sure you cancel those out. And so this right here is going to be our final simplified answer. Any questions on that one? You could, but you're going to be left with two fractions if you do that. Okay, so Haley, let me just show you what would happen if you did what you just said. So if we multiply by 1 over h up front, you're taking 1 over a plus h minus 1 over a, and you're multiplying that by 1 over h. You would then distribute the 1 over h to each of your terms, which would give you 1 over h times a plus h minus 1 over AH. Then you would still need to find a common denominator there to be able to actually combine those fractions, okay? Because a lot of the work that we're going to do down the road, we're going to want all of this stuff combined as much as we can. And so it's probably easier to find that common denominator up front rather than having to do it at this point and then combine. But if you did it, it's fine, right? You're still going to get the same answer. Common denominator this time, we would need the h, the a plus h, and the a. So we would still multiply by a over a, and this one would be a plus h over a plus h. That's going to give us a over ah times a plus h minus a plus h over a plus h. Then when we subtract, again, you're distributing that negative, right? So it's going to give us a negative h up top over a plus h. And then we can cancel out the h's, and we're still going to get negative 1 over a times a plus h. So yeah, you could technically multiply by 1 over h up front, but again, I think if you look, it looks like that's probably even more steps. And the common denominator there obviously has 3 terms instead of just 2. So that's why I think it's easier just to go ahead and combine those fractions up front before multiplying by the reciprocal. Okay. You're welcome. Any other questions there? All right, we are going to skip that one. All right, so rationalizing denominators. So if we have a fraction, and in the denominator we have something in the form a plus b square root of c, we can rationalize that denominator by multiplying the numerator and denominator by what we call the conjugate, okay? So in this case, if we've got an a plus b square root of c, its conjugate is going to be a minus b squared of c. Notice the a value stays the same, and then the b squared of c piece, we just switch the sign. Okay, so if we started with a minus b squared of c, then we would just make it a plus b squared of c instead. Okay, so that's always going to be your conjugate. All right, so let's take a look at this one. So we've got 1 over 1 plus square root of 2, and we're asked to rationalize. All right, so remember on the last slide it said all we have to do is multiply numerator and denominator by the conjugate of the denominator. What's the conjugate going to be for our denominator this time? Good. 1 minus the square root of 2. So we're going to multiply top and bottom here by 1 minus square root of 2. So again, all we've done there is switch the plus to a minus, right? The 1 stays the same, square root of 2 stays the same, and that positive becomes a negative. Now, if we do that, 1 times the 1 minus square root of 2, that's just going to give us 1 minus square root of 2 in the numerator. 1 minus square root of 2 over. And then what are we going to have to do to multiply these denominators now? It's FOIL, right? So we have 2 terms times 2 terms. Group it like that. So if we do that, our first terms here are going to give us what? 1, right? 1 times 1 is 1. The outer terms would give us a what? Negative square root of 2. Good. Then our inner terms, square root of 2 times 1, give us the positive square root of 2. And then finally, positive square root of 2 times negative square root of 2 is what? A minus 2, right? So you could say square root of 2 times square root of 2 is square root of 4. Square root of 4 is just 2. Positive times a negative is a negative. Now, once I combine everything in my denominator this time, what are we going to get? Just negative 1. Good, because we have a positive square root of 2 and a negative square root of 2. Those are just going to cancel each other out. And then 1 minus 2 gives us a negative 1. So now we're left with 1 minus the square root of 2 all over negative 1. And then we can simplify that, right? So rather than just leaving a negative 1 in the denominator, what would that simplify to? You could just put a negative in front of the entire fraction, right? So negative, and then in this case, it would be 1 minus square root of 2 over 1. Or you could just distribute that negative, right? So or divide each terms by a negative. And so we could actually simplify this to negative 1 plus the square root of 2. And that would be our final answer. Okay. But again, in general, anytime you're asked to rationalize, you're just going to look at the conjugate, you're going to multiply top and bottom by that conjugate, and that's going to rationalize. And the whole point of doing the conjugate is so those middle terms cancel out and get rid of the square root. Any questions on that one now? All right. Now, there will be times, especially if you go on to calculus, where you actually want to rationalize a numerator instead. Okay, so in this case, we've got square root of 4 plus h minus 2 all over h, and we want to rationalize the numerator, meaning get rid of the radical in the numerator. So what are we going to have to do this time? So we can, right? So there's nothing technically wrong with that expression as it is. But like I said, there are cases if you go on to take calculus where maybe we're trying to substitute a value in and we can't, like zero in this case, right? If I plug in zero, I get zero in the denominator. But if I rationalize my numerator, it might then be possible to substitute a zero into this expression. And so that's when you would want to do that. But again, yeah, in this case, we're fine with that expression as is, but there are cases where we might want to rationalize. And so that's why we just want to practice it and just make sure we know how to do it. Okay. All right, so if I wanted to rationalize the numerator, what would I have to multiply by this time? Okay, so square root of, now in this case, remember, we don't want to change anything inside the radical, right? We only want to change what? Yeah, the 2 itself, right? So that minus in front of the 2 just becomes a plus. So I'm going to multiply this by square root of 4 plus h, and then we're going to have a plus 2 on the outside. Remember, it's only the sign between the number and the radical that you want to change. And then we do the same thing in the denominator, like that. All right, now we got to multiply the numerators together. So again, this is going to be a FOIL, right? So we got 2 terms here, 2 terms here. What are the first terms going to give us if we multiply? Square root of 4 plus h times square root of 4 plus h. Good, right? So that square root and the other square root, the radicals cancel, and we're left with just what's inside. So we have 4 plus h now. Now, just like before, the outer and inner terms should be opposite, so you don't have to write those down if you don't want to. They're going to cancel, right? And so then we can just look at our last terms. Negative 2 and positive 2 would give us what? Minus 4. Good. Okay, so there's our numerator. Now, in the denominator, I'm going to keep this factored. So I'm going to keep my h times 4, square root of 4 plus h, and then the plus 2. And then our last step would be to simplify, combine any like terms we can. So what are we gonna be left with in the numerator this time? H, good. So we have H over H times the square root of 4 plus H plus 2. And then is there anything else we could do to simplify that fraction? That's right. We have a common factor of H in the numerator and denominator. We can cancel those out. So what am I going to have in my numerator now? A 1, right? So don't forget, we still need that 1 in the numerator. And then our denominator is just square root of 4 plus H, and then a plus 2. Okay. And again, there's no more common factors, nothing else we can do there. We got rid of the radical in the numerator, which is what we were asked to do this time, right? So we can stop right there. And again, in general, for our purposes in Math 171, you're not going to be asked to do that a ton, right? Because in general, we like to get rid of radicals in the denominator, not the numerator. But there are use cases, again, in calculus, where that expression that we got in the end is actually a lot more beneficial to us than what we started with. Any questions on that one now? All right. So that is it for 1.4. So why did I change the H to a K? I didn't. My handwriting was probably bad. Let me go back. Oh, are you looking at this step right here? Yeah, I was trying to mark them out. So that's just showing that the H in the numerator and the H in the denominator cancel, right? So this is like a slash through both of those. Okay, that's all right. All right. Any other questions there? Yeah, it did kind of look like a K. I'll try to be careful and make sure I put longer slashes to make it clear. All right. Let's jump over to 1.5 now. And so this section is just equations. Okay, so we're going to look at solving all different types of equations. And I know that a lot of us are already familiar with solving, especially basic ones. But we are going to review this just to make sure it's clear exactly what we're allowed to do and what we're not allowed to do when solving equations. And then we'll also get into inequalities eventually in this unit. Okay, so in general, the values of the unknown variable, right, that we're solving for an equation is what we call solutions, right? We can also call those roots, and you'll see that when we actually start graphing functions and things down the road, that's probably the term that I'm going to use most often is either roots or x-intercepts. But in general, right, the solutions or the roots are the same thing. Now, any two equations that have exactly the same solutions are what we call equivalent equations. The reason that's useful is because, again, when we get to graphing, if we can show that two equations graph exactly the same and give us the same x-intercepts, then we know that they have to be equivalent to each other. Okay? And so it's kind of useful when we get to the graphing portion to be able to recognize those equivalent equations. All right, so the only thing here really to focus on, we're going to talk about the properties, how to solve in just a minute. But a linear equation is any equation that's in the form ax plus b equals 0. Basically, your x has to be raised to the first power. Okay, so x is your variable. It's raised to the first power. That's the only variable because the a and b are going to be actual numbers in this case. Okay, that's what we call a linear equation to solve. So this right here would be an example of a linear equation, right? Even though we've got multiple x's here, they're both raised to the first power, so we would call this a linear equation. Now, in terms of solving this linear equation, what would be the first thing we would want to do to solve for x? Okay, so we could add 4 to both sides, right? So that's a property of equality that whatever I do to one side, I have to do to the other side, right, to keep the equation balanced. So just keep that in mind. That's going to give us 7x on this side. And then on the other side, we're going to have our 3x. And then we're going to add the 8 and the 4. And so that's going to give us plus 12. Any questions on that step? All right, what could we do next? Okay, so be careful here because we have x's, right, multiple x's, we actually want to get all the x's together first. Good, right? So I'm actually going to subtract 3x on both sides this time. So anytime you've got your variable in multiple locations, try to get all of them together first. Okay, so what's that going to give us on the left-hand side then? 7x minus 3x leaves us with 4x. My 3x and 3x on the other side cancel out, and so we're just left with 12 now. Now that we've got all of our x's together, now what can we do? Now we're going to divide, right? So I'm going to divide here by this 4. And the reason for that is 4x means 4 times x. The inverse operation of multiplication is division. So we're going to divide both sides by 4. That cancels out the 4 on the left. And then what's 12 divided by 4? 3. Perfect. This is our solution. Okay, and in general, linear equations should only have one solution. Now, keep in mind, right, if you're ever unsure if you've done your steps correctly, you can very easily check these, right, because that solution should make the original equation true. So you can go back and plug it in. It's going to give you 7 times 3 minus 4 equals 3 times 3 plus 8. Right? And I put a question mark there because we just want to check and make sure this is actually equal now. Well, what's 7 times 3? 21, and 21 minus 4. 17. Good. On the other side now, 3 times 3 is 9, and 9 plus 8 is 17. Since those are equal, that checks out, and that tells us that our solution is correct. Right? So always feel free, if you want to go back and substitute your value in and just make sure that it works, especially when you're unsure if you've done your steps right. Okay? Any questions on that one now? All right. Let's take a look at this one. Now, this time we've got a whole bunch of variables, but we're trying to solve for capital M this time. So just like before, when we were solving for x, we were trying to isolate x, get x by itself. This time we're trying to isolate the capital M. So what's one thing I could do here that would help us to start to get M, capital M, by itself? Okay, so we could multiply both sides by the r squared, right? Because we have that division there by r squared. Let's go ahead and get rid of that. So I'm going to multiply both sides by r squared. Now, because we don't have any numbers here, right, we can't actually combine things. So this just becomes f times r squared equals, and on this side now, my r squared and r squared cancel out, and I'm left with g times little m times big M. Any questions on that step? Okay. Again, keep in mind we're trying to get big M by itself. What can we do next? Good. We can divide both sides here, and we can actually divide by the g and the lowercase m at the same time, right? Because they're both being multiplied. We're trying to get rid of both of them. We're going to divide by g m on both sides. So in this case, the g's cancel, the m's cancel on the right-hand side. That leaves us with our capital M that we wanted. And again, on the left-hand side, none of those terms are the same. There's no common factors. We can't cancel anything out. This just stays f r squared over g m. And so this would be our solution to that equation now. So don't panic when you don't see numbers, right? When it's all variables. Honestly, a lot of times those are even easier to solve because you don't have to worry about making, the careless errors of subtracting wrong or adding wrong or dividing wrong, things like that, because you're not really combining any of those terms, right? So just try to move everything away from the capital M in this case. Just make sure we're using multiplication, right? Those are the inverse operations here to move everything over. Any questions on that one now? All right. There we go. All right, so the surface area of a closed rectangular box, shown in the picture below, can be calculated from the length, the width, and the height. Okay, and so here's our formula for surface area for that box. We want to solve that formula now for W. So basically, this time we're trying to get little w by itself. And so I'm going to create another slide here just so we got plenty of room to work this out. And I'm just going to copy over my formula. So we had A equals, copy it directly, 2LW plus 2WH plus 2LH. And again, we're trying to solve this for W now. So what could we do first here if we're trying to get W by itself? Okay, good. So we've got one term that doesn't have any W's at all. So let's go ahead and move it to the other side. So I'm going to subtract 2LH from both sides. That's always going to be the case, right? If you've got any terms that don't have the variable you're trying to solve for, go ahead and move those. Now, on the left-hand side, none of that's like, right? So you can't combine it. So this just becomes A minus 2LH. And on the right, we're left with 2LW plus 2WH. All right, now notice this time we've actually got two terms that have the variable that we're trying to solve for. So we can't just get the term by itself and then divide. Any ideas on what we might be able to do though? Okay, so we can't divide yet, right? Because we've still got that addition in this one, and we're trying to get W by itself. Okay, but that W is in two different terms. Common factor, good. So what is the common factor on the right-hand side that we can bring out? Technically 2W, right? Okay, now in this case, because it's really W that I'm trying to solve for, I'm only going to bring out the W, right? I'm going to leave the 2 in there so that I can try to get this W by itself. If I factor out W, what's left in that first term? 2L. And what's left in the other term? 2H. Good. Okay, so now I have W times 2L plus 2H on the right-hand side. Again, I'm trying to get W by itself. So what could I do now? Divide, right? So because I've got multiplication over here, I'm just going to divide both sides by everything that's in those parentheses so that I can cancel it out. So I'm going to divide by 2L plus 2H. And then do the same thing on the other side. So now that factor cancels out with the 1 in the numerator. So I'm left with just W over here. And on the other side, again, because there's that addition and subtraction, there are no common factors that are going to cancel out. Nothing's exactly the same. And so this becomes A minus 2LH over 2L plus 2H. And that would be my answer. So the key here is just to make sure, right, that you're solving for W. That means we can't have any W's on the other side when you're done. If you're left with a W on the other side, then you know you did something wrong. Okay, but in this case, we've only got A's, L's, and H's on the other side. That is our equation, and that is solved now. Any questions on that one? All right. Quadratic equations. Okay, so a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0. A, B, and that should be C, sorry, not X, are real numbers, and A can't be 0, right? Because if you put a 0 in front of the x squared term goes away, and it becomes a linear equation instead. Okay, so we're just saying that A can't be 0. Now, in general, right, anytime you've got an x squared term as your highest exponent, that makes this quadratic. Right? So that's exactly what we're looking for to determine if we have a quadratic equation. And now this zero product property at the bottom is going to be very useful for us when solving, okay? So if we have a product, A times B equals 0, that means that either A has to be equal to 0 or B has to be equal to 0, because the only way you can multiply two things together and get 0 is if one of those things is 0 itself, okay? The reason that's going to be useful is because we're going to do some factoring. We're going to end up with multiple factors that are multiplied together. And this zero product property then tells us that one of those two factors is going to have to be equal to 0 to make the product equal 0. So that's how we're going to solve quadratic equations now. All right, so let's take a look at this one. We got x squared plus 5x equals 24. And we want to find all the real solutions of that equation. Okay, now the first step whenever you're solving a quadratic equation is we're going to set it equal to 0. Right? So we want to move everything to one side of our equation. So what's the first thing we're going to want to do here? Minus the 24. Good. Subtract 24 on both sides. Okay. Notice there are no number terms on the left, so nothing to combine it with. So this is going to give us x squared plus 5x minus 24 equals 0. Now, once we set our equation equal to 0, what do you think we're going to do next? Now we need to factor. Good. All right, so think back to all those things that we did back in section 1.3. Right? If we want to factor this now, what am I going to start with? Good, right? So we know to get x squared, the only option there is an x times an x. And now we're going to look at what? Good. So if we think about the factors of 24, what are the options? Okay, so we could do 3 times 8. We could do 6 times 4. We could do 1 and 24 for sure. We could do 12 and 2, right? And those should be the only options there that would give us a 24. Now, in this case, because we know we're trying to get a 5x in the middle, which one of those do you think we might want to try first? Yeah, the 8 and the 3, right? Because in this case, if I do 8 here and 3 here, we know we want a negative 24, so the signs have to be positive and negative. And so if I add 8 and subtract 3, that's going to give us a positive 8x and a negative 3x, which would give us the 5x that we want in the middle. Okay, so that is our factored form this time. Any questions on that step? All right, now make sure here we're not stopping at that point because we're not just simplifying this, we're actually solving. We want to know all the real solutions to that equation. Once we have it factored, what can we do next? Good. Now we're going to take each of our factors and we're going to set them to 0 because this goes back to that 0 product property that if the product of x plus 8 times x minus 3 equals 0, one of those two factors has to equal 0 to make the product equal 0. So x plus 8 has to equal 0 or x minus 3 has to equal 0. Now it's just a matter of solving each one of those. What would I do to solve this first one for x? Subtract the 8. Good. And so that's going to give us x is equal to negative 8. Or, and if we do the other one, what are we going to have to do to solve that one? Add the 3. Good. And so that's going to give us x is equal to positive 3. Notice here, this time we get two solutions. So either x is equal to negative 8 or x is equal to positive 3. And again, if you go back and substitute those values into the original equation, both of them will give you a true statement. Right? So both of those solutions will work in the original equation. That's why we get two solutions to this one. All right, so that's where we're going to stop for today. Again, make sure that you get the 1.1 to 1.4 homework done by midnight tonight. Send me questions if you have any on that. Again, you'll be able to go ahead and get started on the 1.5 homework if you want to now, because we've done a few of the equations there. But we will pick up with this on Wednesday. And again, the goal is to get through the rest of chapter 1 by middle of next week or end of next week so that I can post the test and it should be due next week. Okay? Any questions, comments, concerns? I'll hang out for a few more minutes if you got any. Otherwise, I'll let you go. Have a great day, and I will see you all on Wednesday.